Today we're going to evaluate two variable functions. Remember that a function is a rule that takes an input or an element from our domain and maps it to the output or an element in the range. Let's look at an example really quick. What's the value of g of x equals 5x plus 1 when x equals 3? Let's use that function notation here to plug in that 3 into our function, replacing x with 3. G of 3, when I simplify, equals 15 plus 1 or equals 16. G of 3 equals 16. What did we do? We evaluated a value of x of our domain, one of our inputs, into our function, and we got an output, 16. Functions can also be defined by more than one variable. That's what we're going to do today. The diagram below shows a function defined by two variables. The function has two inputs and a single output. As we take a and b and we plug it into our function, a single output is coming out. This can be written as f of a and b equals 5a plus b. Let's actually practice with that in our first example. Number one, we're going to evaluate each function for the given values. And number one is that 5a plus b. We're going to evaluate it for f of 4 and 7. So all we're doing here is plugging in 4 and 7. 4 is listed first. So 4 for the a and 7 for the b. I replaced the a with the 4 and the b with the 7. So let's keep evaluating like we did before with one variable. I'm going to get 20 plus 7, or f of 4 and 7 is 27. We have two more examples. We've got g of x and y equals 2x plus 10y, and we're going to evaluate for g of 2 and 3. 2 is listed first, so I'm going to plug in 2 for the x and 3 for the y. G of 2 and 3, simplifying, I'm getting 4 plus 30, or G of 2 and 3 is going to equal to 34. In number 3, we're evaluating H of 4 and 1. So I'm going to replace this C with the 4 and the D with the 1. H of 4 and 1 is going to give us 24 minus 5, or H of 4 and 1 is going to equal 19. Let's apply it into a context. Number 4, Asher is shopping for school supplies. His mom gives him $30 to spend at the store. Notebooks cost $3.50 and pens cost $1.75. Write a cost function C to find the total cost of buying notebooks and pens. So I'm going to write something like the function C of notebooks and pens is equal to. And then we do have the question at the end, can Asher afford 6 notebooks and 10 pens for school with his $30? So we do know notebooks cost $3.50. I'm going to do $3.50 N plus $1.75 for the pens P. There's my function. Very simple, very basic. And let's evaluate it for the 6 notebooks and the 10 pens to see what we get. So plugging in 6 for the notebooks, 10 for pens. C of 6 and 10. The $3.50 times 6 is going to give us $21, plus the $1.75 times 10 is $17.50. C of 6 and 10, when I add those together, is going to give us $38.50. Can Asher afford 6 notebooks and 10 pens with his $30 to spend? No. So answering that final question, can he afford the 6 notebooks and 10 pens? No, Asher cannot not afford 6 notebooks and 10 pens. The cost is $38.50, which is more than he has to spend. Make sense? On page 2, we're going to look at using symbols to represent our operations. Symbols such as that circle with the X in it can be used to represent non-standard operations. Let's define that symbol, the 0, the O with the X in it, as a symbol B equals 3/4 times the quantity of A plus B. The output is going to be equivalent to that A operation B. So number 5, let me show you how we can work this one. So we're evaluating 6 operation 10. Same as we did before, we're plugging in the first value for the A value. So we had 3/4 A, that's our 6, plus the second number 10 is going to go in for B. So 6 operation 10, 3/4 times 16, or final answer, 6 operation 10 is going to be equal to 12. Let's try it again with number 6. There's actually 2 layers here. We are going to perform our parentheses first. So we'll have 11 operation quantity of 4 operation 8. So starting with the inside, we'll still have that 11 operation inside. Let's go ahead and put that 3/4 of 4 plus 8, still using that original defined operation. 11 operation of 3/4 of 12. That's going to give us 11 operation. The 3/4 of 12 makes 9. Now do that second layer. We have 3/4 of 11 plus 9. That's 3/4 of 20, which equals 15. So those can be a little tricky. I even find them a little bit intimidating. So just go nice and slow. No need to rush. Let's look at a few more examples. Number 7, we've got M operation N has been defined differently. So we're using a different function here. 3mn minus 1. And we are going to plug in 5 and 9. So 5 operation 9. We have 3 times 5 is our M. 9 is our N, minus 1. 3 times 5 times 9, multiplying those together, you can use a calculator, is 135. Minus the 1 is 134. Number 8, a different operation has been defined, and we are plugging in 4 and 2. 4 operation 2, we're plugging in 4 for J. K is bumped up multiplying, and we're replacing that with 2. In the denominator is J, which we're using 4, plus K is 2. I have 8 over 6, or I could simplify that fraction as 4 over 3. In number 9, we have C operation D. Here's our new function, C minus 3D. But look how we're evaluating it. It has the double layer in there. We have parentheses. So let's go nice and slow. We are doing 4 operation quantity of 5 operation 8. So let's slowly plug that in. Let's leave the 4 alone, 4 operation, and let's do the parentheses first. We're plugging in 5 for C, minus 3 times 8 is D. So in the parentheses, 5 minus 24, which is going to give me a negative 19. And so we're ready to apply that operation again. We've got 4 is our C value, minus 3, and plugging in for D the negative 19. 4 plus 57, negative 3 times negative 19, you could use a calculator, gives you the positive 54. And last step, 4 plus the 57 gives us 61. So there's evaluating 2 variable functions. You could have a traditional written out, of course, using that function notation. Work through these carefully. And then the symbols, that is just another way to write it. Again, nice and slow. If you're struggling with that, let me know, and I'll be glad to help. I hope y'all have a great day. See ya.